tension running high for this game. Nice forehand shot. There's a top spin on that one.
眼睛不要擦亮，记住我的模样，表情不用太紧张，我是3年2班，我专心感觉得这脸还蛮好看，每一把星星守着睡的地方，只是早上的阳光那眼神我不太喜欢，没有叉叉的自然，会更比较漂亮，这都是在等比赛，还有考卷的答案，不敢跑都不会算，没关系，再继续努力，没关系，可是举手很难，为什么那些上方无其他？为什么女生不喜欢太胖？为什么别人手机在响？
Under the first rule, whoever reaches 11 first will win the game. There are only 8 possible intermediate and final outcomes, given that Keathong and Edison are 9 all, as shown by the notes in the diagraph. The scores are given as Edison's score and Keat Hong's score. The set of all these possible scores are called the state space of the Markov chain. Assume that each point is scored independent of the previous result. The probability of Edison's score is P, and for Keat Hong is Q. P plus Q equals to 1. This is the primary assumption of a Markov chain. Since Edison and Keat Hong are well-trained Ping Pong Masters, their performance is independent of how much they have already scored. Otherwise, we cannot call it a Markov chain. Hence, the probability of getting from 9 all to 10 9 is P, to 9 10 is Q. From 10 9, the chances of getting to 11 9 is P as well, and to 10 all is Q. Similar for the rest of the digraph. Q, and this P, this Q. We say a class is open if there's a way to go out, but there's no way coming back. There's no incoming arc to 9 all, so this is an open class. There is incoming arc to 10 9, but after it go out of the class, it cannot be coming back because the incoming arc is from 9 all, which is an open class. So 10 9 is an open class as well. Same logic applied to 9 10. And since both of them are open class, 10 10 is an open class as well. We say a class is closed if there's a way coming in, but there's no way to going out of the class. Hence, there's no outgoing arc for these 4 states, so these 4 states are closed class. Starting at 9 all, what's the probability of the game ending up in these 4 final scores? Technically, we call this probability the absorption from 9 all to each of the closed classes. A 9 9, 11 9 is the probability of the game ending up 11 9, given we start at 9 all. Since the states are independent, we can just multiply the probability along the path. From 9 9 to 11 9, the probability is P times P equals to P squared. From 9 9 to 11 10, there are 2 roots. One is PQP plus QPP equals to 2P squared Q. Same logic can apply to 10 11 and 9 11. So for 10 11, the probability is 2Q squared P. For 9 11, the probability is Q squared. Since these are the only 4 outcomes of the game, so the probability of these 4 outcomes should sum to 1. Hence, P squared plus 2P squared Q plus 2Q squared P plus Q squared equals to P plus Q squared equals to 1. Note that the game will only finish in maximum 3 steps once we reach 9 all. Under the second rule, whoever leads by 2 will win the game. There are infinite possible outcomes if Keathong and Edison always reach a tie. Our previous approach is not the most efficient way to calculate the probability. However, we can analyze the problem from a different angle. Instead of looking at the scores, we can classify the states by how much Edison leads. Hence, the states are -2, -1, 0, 1, and 2. Keat Hong will win if the process reaches -2, and Edison will win if the process reaches 2. This is called a gambler's dream problem. We can imagine Keat Hong and Edison are 2 stubborn gamblers. They bet on the score difference. Each of them has 2 cents to gamble. 1 cent for each game if a point is scored. They'll only stop until one of them goes bankrupt. Edison's wealth change is equivalent to the score difference. The game goes on and on until one of them leads by 2 and one of them goes bankrupt. Let K denote the total wealth of Edison and Keat Hong. In this case, it's 4. Let I denote the initial wealth of Edison, which is 2. The probability of Edison scores a point is P, and Q for Keat Hong. P plus Q equals to 1. As the last example, assuming their performance is not affected by how much they have already scored, probability of Edison wins is I over K if P and Q equals to half. The probability of Edison wins a game if P and Q is different is 1 minus Q over P to the power of I over 1 minus Q over P to the power of K.